everyone, today we learned to connect components in series and parallel and to read circuit diagrams. So today I'm using AA batteries. These are 1.5 volts batteries. These are alkaline batteries. Make sure you don't use rechargeable batteries. So here the plus of the battery is the red wire. Red wire is the plus of the battery and the black wire is the minus of the battery. So when you clip alligator clip to this, make sure it's clipped to the metal part of the wire and not the red plastic. So in the previous lesson, we learned that an LED needs 3 volts from battery to light up. So we have a 3 volts battery here. The two AA cells are in series here. So it makes a 3 volts battery. So now let's connect an LED and a resistor. Let's take a 220 ohm resistor. You may start building the circuit along. So we get a red alligator clip and clip to the plus of the battery, and then connect the other end of the alligator clip to the resistor. Now resistor doesn't have any polarity, so it doesn't matter which way you connect it. Let's grab another alligator clip and connect it to the LED. Now here, this needs to be connected to the long leg of the LED because LED has polarity. The long leg is the positive, which needs to be closer to the plus of the battery, and short leg is the negative of the LED, and that gets connected to the minus of the battery. So let's take another alligator clip and connect the short leg of the LED to the black wire of the battery. That's the minus of the battery. And there, that's our circuit. So here in our circuit we have the plus of the battery connected to the resistor, and the resistor is connected to the long leg of the LED, that's the plus of the LED, and the minus of the LED is connected to the minus of the battery. Now let's draw what we see here. You may pause the video here and try drawing a diagram of this circuit on a sheet of paper. Let's start with the battery. We have a 3 volts battery here, which is two 1.5 volt cells in series. So let's start by drawing the two cells. So here is our first cell. Here is the second cell. Both are 1.5 volts. Here is the plus of the first cell, is the minus, and they are connected in series to make it into a 3 volts battery. So there. So that's our 3 volt battery. Now, the plus of our battery is connected to a resistor. Let's use a rectangle to represent that. And it is a 220 ohm resistor. This is the symbol for ohms. Now, the other end of the resistor is connected to the long leg of our LED, which is the plus of the LED. And there, the short leg, that's the minus of our LED, is connected to the minus of the battery. So that's it. That's our circuit. So if you've drawn something like this or neater, you did great. So circuit diagrams are like the language of circuits. We read these diagrams to build circuits. Over the years, people have arrived at certain symbols for components. So there is a symbol for every component. Just like we have alphabet in a language, we have symbols for components. So anyone who reads your circuit would know the component you have used. Now let's look at some of the components, some of the symbols for common components. So here, the first one, that's a single cell. So the long line represents the plus side of the cell. The short line is the minus of the cell. So here is the symbol for the two cells battery. It's got one long line and short line, which represents one cell, and then another set of long and short line, which represents the second cell. So in our circuit, we have two cells in series, which make it into a 3-volt battery. So this is the symbol we'll use. Now, the symbol for LED is a triangle with two arrows, and then LED has polarity. So here we have the plus sign on the left and the minus sign on the right. Resistor is a rectangle, and then these are the symbols for different switches. So this is a simple on and off switch. It's also called SPST. And then this is another, it's a 3-pin switch. It's called double throw switch. We'll use each of these in our circuits later. And this, you can use any of the two symbols for the motor. So now let's substitute these symbols one by one in the diagram we just drew. So you may pause the video just right here and try substituting these symbols in your diagram, or you may do it along. So let's first substitute the symbol for the battery. So here we have two 1.5 volt cells which make a 3 volts battery. So this is the symbol for 2-cell battery. Let's substitute this symbol in our diagram. There. Now next, the symbol for the resistor. That's a rectangle. We already have a rectangle in our circuit diagram, so we will leave it as it is. And then for the LED, look, the LED, the plus of the LED is on the right in our circuit and minus is on the left. And this is the symbol for the LED with the triangle and two arrows pointing outwards. So now this symbol should be placed such that the plus remains on the right and minus remains on the left. So let's go ahead and change the symbol. And there, that's our circuit diagram. Ta-da! You got your first circuit diagram ready. Good job. So now let's look at our circuit and the circuit diagram. So here we have a resistor and an LED connected one after the other in the same loop. So this kind of connection is called a series circuit. So now let's add another resistor in series with our LED. So let's go ahead and add another resistor here. I am using a 120 ohms resistor. You may use a resistor with any value from 50 to 1000 ohms to make your LED as dim as you like. So here, let's connect this resistor to the short leg of the LED. Let's get a new alligator clip. Clip it to the short leg of the LED, and the other end of the alligator clip goes to 120 ohm resistor, and the other end of the resistor goes to the minus of the battery through the black alligator clip. So here we've got two resistors and an LED in series. They are all in the same loop. Now let's remove the second resistor and add another LED here. So let's remove the 120 ohm resistor and add another LED here. I think I'll choose a blue LED today, not because I'm feeling blue. I'm very happy building circuits. I just like the blue color. You may choose any LED of any color. So you may choose LED of any color you like. It's your circuit. The short leg of the LED of the blue LED is connected to the minus of the battery. So green LED is connected to the long leg of the blue LED, and the short leg of the blue LED goes to the minus of the battery. Make sure you get the polarity right. So now what happens? The circuit is closed, but none of the LEDs light up. Our circuit is closed. Now we've got two LEDs and a resistor, and it's a closed circuit, but the LEDs don't light up. That's because each LED needs around 2.5 volts to 3 volts to light up. And in series, the voltage needed for these LEDs together is more than what the 3 volts battery can supply. We can use a multimeter to get the exact reading across each of the LEDs. For now, let's look at another way of connecting these two LEDs in this circuit. Now, is it possible to light up both the LEDs with just 3 volts of battery? Well, there is a way, by connecting them in parallel. We'll explore this in our next video lesson.